So this is where your notes packet begins. So this is the top right box on your notes packet. And what this is showing you is sort of the formula, and I hesitate to even use the word formula, but sort of the process. Anytime you're asked to factor the difference, and difference means this is subtraction, and remember how important that was a second ago. That's what lets us have the one positive and one negative. The difference of two perfect squares, and that means some number that has been squared or some letter that has been squared. So it might be an x squared, might be an a squared, might be a 36 because 36 is 6 squared, might be a 100 because 100 is 10 squared. Anytime these two things are both perfect squares and there's a minus in the middle, that's when this works. You can factor by just splitting up this one and splitting up this one into what their square root really is. That's why this says the square root. And then put them in parentheses with one with a plus and one with a minus. Okay? And again, that plus minus thing comes from the fact that this back here was a minus, and remember that anytime it's a minus, you're going to do a positive and a negative. So let me show you how this works, because it sounds a lot more confusing than it really is. So say, for example, I have x squared minus 36. Actually, I'm going to jump ahead and put all my examples up here. So these are the 4 examples you should see in your notes packet. And I had to block out all the answers because my copy had all the answers written in. So that's what that big rectangular box is. But we're going to work through these together. So x squared minus 36 can factor into an x plus and an x minus, just like before. And then remember, what you're thinking of is two numbers that multiply to 36 and subtract to 0. Well, that would be 6 and 6. So it would be x plus 6, x minus 6. Okay? The shortcut to that is to say, all right, x squared breaks down into x and x, and 36 breaks down into 6 and 6, and those are both perfect squares. So let's talk about that next one, x squared minus 16y. Whoops. All right, ignore random circle there. Resize the screen and can't get that to move. So x squared minus 16y squared. So once again, this is a perfect square because it's something squared. Okay, 16 is a perfect square because it's 4 squared. And then this also has a y squared on it, but that's a perfect square also. That'd be y and y. So when I go to write this one out, it would be x plus square root of 16 is 4, square root of y squared is y. And then the same thing with a minus, x minus 4y. Every single one of these is really that easy. 9x squared minus 49. So this time I've got a number out in front, but it's again a perfect square. 9 is equal to 3 squared. So square root of 9 is 3, square root of x squared is x, minus, and square root of 49 is 7. Whoops, I guess I can make that a plus first. It actually wouldn't matter, but I just did all the other ones plus first. So 3x minus 7. So it's always going to be exactly the same thing, one with a plus, one with a minus, every single time. And again, I shouldn't have even bothered to change that one because it doesn't matter what order you put them in. Okay, this next one's kind of interesting. So if I break up 16, that's going to be a 4. If I break up x to the 4th, remember you have to think about like what times itself would make x to the 4th. That would be x squared. Okay, and then 81 is 9 times 9. So this is going to be 4x squared plus 9, 4x squared minus 9. Okay, now I'm doing this to you because I think these problems are cool, but I promise you they don't come up a whole lot. Okay, but this is a very unique one, where if you look at the second parenthesis there, the 4x squared minus 9, that, because 4, x squared, and 9 are all perfect squares, that is another one of these problems. So that 4x squared minus 9 can actually be factored again. I could take that 4x squared minus 9 and break it up into, let's see, square root of 4 is 2, square root of x squared is x, and then one's going to be a plus, and the square root of 9 is 3, and then the other one would be, let's slide this over some, whoa, there we go. The other one would be 2x minus 3. So those two parentheses came from just this, the 4x squared minus 9. Okay. Now this one, because I get a lot of people ask when I do this example, well, why can't that one break down? This one can't break down because it's a plus. Remember, this only works when it's a minus. Okay, so that 4x squared plus 9, that's as factored as it gets. So that one's going to stay put. So again, this is sort of a unique example that doesn't come up a whole lot, but I wanted you to see that sometimes you're not done factoring, when you think you are. Okay, so you always got to kind of watch out for that. Again, though, don't stress out about this. This is not something that pops up a whole lot. The only time it would happen is if after you split it up, the two numbers that were left over here were also perfect squares, okay, which they were in this case. It was a 4 and a 9. But had these been just any other random numbers, this wouldn't have worked. Remember, this only works when this is a minus and when you've got two perfect squares. Okay, now I've got a couple in Nearpod there for you to try, and then you can get started on the homework for today.